Hello, welcome back to Mr. Kenner's online math class. This is lesson 3.3, one-step equations with addition and subtraction. Go ahead and turn to the next blank page in your math notebook and write this lesson title at the top. Alright, to solve one-step equations, we're going to use the inverse operation to isolate the variable. So a couple things to start. Inverse operation means opposite. The opposite operation. Operations are addition, subtraction, multiplication, and division. So we're going to use the inverse, the opposite of addition, subtraction, multiplication, or division to isolate the variable. And to isolate the variable just means that we're trying to get the variable by itself. And remember, the variable is just a letter that is taking the place of a number, taking the place of an unknown number. Okay, so we're going to use the inverse operations to isolate the variable. So that means when we see addition, we want to use subtraction. So when we see addition, we want to use subtraction to get the variable by itself. And when we see subtraction, we want to use addition to isolate the variable or to get the variable by itself. Okay, so go ahead and pause here. And make sure you write this information down in your notes. Alright, on this slide I would like you just to watch as I solve for the value of x by isolating the variable. Okay, so in these equations, this equal sign, the equal sign tells us that the left side is equal to the right side. So both sides of the equation are equal. And our job is to figure out what is the value of the variable. And we have to do that by getting the variable by itself. So in the first one we have x plus 2 equals 8. Okay, and the most important thing is if we do something to one side, we have to do the exact same thing to the other side of the equation. In this situation, we see plus 2 with the variable, so we need to do the opposite or the inverse operation to get rid of that 2 from the left side of the equation. So what I'm going to do is I'm going to subtract 2, so minus 2. And whatever I do to this side, I have to do the same to the other side, so this would be minus 2. And then plus 2 minus 2, these will cancel out. So there'll be just x left on this side. And then 8 minus 2 will leave us with 6. So our equation would read as x equals 6. And whenever we find a value for the variable, we can always check it by plugging that value in for the variable. So that would look like 6 plus 2 equals 8. And that is correct. So our value for x is accurate. Alright, for the second one here we have 5 equals x minus 3. Okay, and I'm just going to draw this line from the equal sign just so I can always keep track from left to the right side of my equation. So I have x minus 3, so I'm going to do the opposite or the inverse operation of minus 3, which is plus 3. And then whatever I do to one side, I have to do to the other. So I'm going to add 3 to the other side, and I'll get 8 equals x. Because negative minus 3 plus 3, they cancel out to equal 0. And again, we can check our answer by plugging the value that we found in for the variable. So that would be 8 minus 3 equals 5. And 8 minus 3 is 5, so that is correct. Alright. Alright, so you got to watch me go through a couple examples. Now it's going to be your turn. Solve for the value of the variable. So in each of these equations, we're trying to figure out what is the value of the variable. Okay, so you can go ahead and pause here, try these problems out on your own, and then resume the video and see how you did. Alright, for the first one, we have x plus 5 equals negative 1. Okay, so I have x plus 5, so I'm going to do the inverse operation there. So that's going to be minus 5. Minus 5. Whatever I do to one side of the equation, I must do to the other. So then we would be left plus 5 minus 5 equals 0, so those cancel out. And we have x equals negative 1 minus 5, or negative 1 plus negative 5 would give us negative 6. If we plug that back in in our equation, we have negative 6 plus 5 equals negative 1. And negative 6 plus 5 would equal negative 1. So x is equal to negative 6. Alright, for b, we have negative 4 equals m minus 18. So we have a minus 18 on the same side as the variable. So in order for us to get the variable by itself, we're going to add 18 to both sides. And then minus 18 plus 18 will cancel out. And then we have negative 4 plus 18, which would leave us with a positive 14 equals m. Okay, and again, if we plug that back in to our equation, 14 minus 18 equals negative 4. And 14 minus 18, 14 minus 14 would get us to 0. And then there's 4 more, that would be negative 4. So the value of m is 14. Alright, c, we have negative 9 equals negative 5 plus w. So we have negative 5. We're going to have to do the opposite, or the inverse operation of negative 5, which is plus 5. What we do to one side, we have to do to the other. Minus 5 plus 5 cancels out. And then negative 9 plus 5 will equal negative 4. We plug that back into our equation. Negative 5 plus negative 4 equals negative 9. Negative 4 is the value of w. Alright, d, negative 14 plus x equals 45. So we have a negative 14. In order for us to get the variable by itself, we have to do the inverse operation. So that's going to be plus 14. Plus 14. Negative 14 plus 14 cancels out. And 45 plus 14 will be 59. 59 is equal to x. And if we plug that back in, negative 14 plus 59 equals 45. We have different signs here, so we're going to take the absolute value. 59 has a greater absolute value, so our answer is going to be positive. And we have 59 minus 14, and we would get 5 and 4. So the value of x is 59. Alright, a couple more for you to do on your own, so go ahead and pause now. Try these 2 examples and then come back and see how you did. So for the first one, we have x plus 3/5 equals 3/15. Okay, so we have plus 3/5. We're going to do the inverse operation, so that's minus 3/5 minus 3/5. Okay, so this one will take a little bit more work because we're subtracting fractions, so we need common denominators. So we have 3/5 minus 3/5. So I'm going to use 15 as my common denominator, so times 3, and then we have 3/15 minus 9/15, and 3 minus 9 will leave us with negative 6/15. So if we go back to our equation, 3/5 minus 3/5 cancel out, and 3/5 minus 3/15 minus 3/5 is negative 6/15. So x equals negative 6/15. And if we plug that back into our equation, it would say negative 6/15 plus 9/15 equals 3/15. And negative 6 plus 9 will give you a positive 3/15. So the value for the variable is negative 6/15. Alright, for the second example, we have 25 equals negative 7 plus x. So we have negative 7. We're going to do the inverse operation, so that's plus 7 to both sides. And we are ended up with 32 equals x. And if we plug that back in, 25 equals negative 7 plus 32. And negative 7 plus 32, or 32 minus 7, and keeping positive because 32 has a larger absolute value, would be 25 equals 25. So that our value for x is 32. Alright, I got a couple more slides here. We're going to take a step a little further here. I'm going to go through this example. I want you to watch me do it, and then I want you to write this example down. So it says, find the value of 2x minus 1 when x plus 6 equals 2. So when x plus 6 equals 2 tells us that we need to find the value of that x first and then plug it into, we're going to find the value of this equation here, and then we're going to plug it into here. Okay, so when x plus 6 equals 2, so we're going to have to subtract 6 here, subtract 6 on both sides, and then we'll have x equals negative 4. So when x is equal to negative 4, we need to find the value and plug it back into this 2x minus 1. So it would look like 2 times negative 4 minus 1. And 2 times negative 4 would be negative 8 minus 1. Oops. One step ahead of myself there. Negative 8 minus 1 would equal negative 9. So whenever we have to find the value of an expression when we have an unknown value for x, we need to find the value for x first and then plug it into our expression. So make sure you write this example down in your notes. And then I got one example for you to try. Find the value of 5x minus 12 when 7 plus x equals negative 3. So first, find the value of x here, and then plug it into this equation here. Go ahead and pause, try this one out, and then see how you did. Alright, so when 7 plus x equals negative 3, we got to isolate the value of the variable x by doing the inverse operation of plus 7, which is minus 7. And then we have to do it to both sides, and minus 3 minus 7 would give you negative 10, so x is equal to negative 10. Then we're going to plug that into our expression over here, 5 times negative 10 minus 12. So 5 times negative 10 would be negative 50, and negative 50 minus 12 would be negative 62. So remember, when you're trying to solve for the value of a variable in an equation, we need to make sure that we isolate the variable by using the inverse operation of the value in our equation.